Now relays are stunningly easy things to build actually. They're little more than a contact switch and a solenoid is a coil of wire around an iron core, and they work great. So we're going to build a relay, but we're not going to build a relay like that. We're going to build a more sensitive relay. So I want to go through how to build a super sensitive relay. Now, first thing we need to do is make a coil of wire, and to do that we need a bobbin. I'm going to use a sheet of this. It's high impact polystyrene. It's strong enough we can cut the shape out that we want, and we can make that bobbin up. So let's get on with that. So we've used the hips to create these two windows. So we've got a couple of windows like that, and the centres of those actually I'm going to glue upright in there, and then that window goes on top like that, and we have a couple of little pieces to go in there, which we put in there like that. So all we do is super glue those in place. And when you've done that, that's what you end up with. Now obviously it can be any shape you want. We want this letterbox shape for specific reasons, but it could be round as well as square like this. And to finish this off, what we need to do is wind some wire around. Now you don't need to go too bananas about the wire, but there is a little bit of guidance if you like. The thicker the wire, the lower the resistance, so more current will pass. However, we've got to stick it in a known volume, and as the magnetic field is related to the number of turns of wire as well, then we need to get as many turns as we can on there to get a nice strong field. It's, you know, pros and cons about one and the other. Really just go with what's sensible. I mean, don't try to stick some 16mm cross section across there. Equally, don't try to put something that's so hair thin you can't work with it. I'm going to use this gauge actually, which I think is a 20 gauge, I'm not sure, something like that. But it's reasonably thick so I can handle it, but reasonably thin so that I can actually get enough turns around there. Now, all I'm going to do is wind a bunch of this onto this by hand. So there's coil finished and glued onto a bit of blue baseboard. It's just a bit of acrylic. I've put them on a couple of brass pins so that we can connect to it. Now what we need is a hacksaw blade. And you need to cut off a section of the hacksaw blade, some section that's going to go through there. Cut it off, take off the teeth and put this to it so that we can put it in a block. Now handily enough, it's got a 4mm hole there, so we can put a couple of cap nuts on a bit of 4mm bar like that. And then on the other end we crimp on a connector, so that connector will fit in there and crimp on. And we've done that, cut out a block, and obviously it's the thickness of a hacksaw blade, cut a slot in it so that we can actually glue that hacksaw blade in position, and the hacksaw blade glues in like that. When we've done that, what we need to do is add a big old lump of metal. Now this stuff actually is from a transformer, a microwave oven transformer. So that gets fixed in place like that, and that lump of metal gets fixed in place there. So it's all down the centre line. Okay, so that's it finished. Now what you're looking at here, obviously, is a relay. There's the common pole going through the hacksaw blade, and here I've put two bolts with dome nuts on them that are touching the dome nuts on the hacksaw blade. These ones are touching now, so that's the normally closed pole, and these ones are open, so that's the normally open, and that would act like a relay. Actually, it won't be very good like this, and here's the trick, and it's the one that I really like actually. We've got a couple of neo-magnets here facing north-south, north-south, and what we do is put those on that metal bar. Now these are quite strong, so it's going to be a little bit of trouble for me to get, there we go. So we put them in the same orientation, north-south, north-south, and shove them closer. And now this is sitting in a permanent magnetic field, and you can see it's pulled it towards that there, and it's a very definite click as it pulls it towards it. Okay, so I've set it up just as a normal relay, and you can see that the light is on because I've got it on the normally closed. Now if I apply a voltage to the coil, there we go, it turns itself off because it's moved away. Now it's moved away but not sufficiently to touch this other one. What I have to do is increase the voltage some more, and that will pull it all the way across. But it works just fine as a normal relay. So why not just get a normal relay? Why bother to make this balanced magnetic field that you're disturbing? Well, I think there's actually more advantages to this. Now, it's not immediately apparent, but the voltage applied needs to overcome the magnetic attraction here. Now, voltage and magnetic attraction for a given coil are fixed relationships. That is, I create a fixed magnetic field for applying a certain voltage. If I apply that same voltage, I'll have the same strength of magnetic field. What that means is the distance of that magnet from here is going to fix the voltage at which that turns off. That's really cool, actually, because normally, obviously, with a relay, you have voltage that the coil will do. Here you could actually set the voltage, the turn-off voltage. Now the turn-off voltage and the turn-on voltage aren't necessarily the same. You can set them the same just by setting the distance here a little closer, and then the turn-off and turn-on voltage would be identical. But this thing sweeps through an arc depending on the voltage applied. But every time I apply a fixed voltage, it will go to the same point. What that means is that for different voltages we could have a multi-switch here. We don't have to have either normally open, normally closed. We can have lots of normally closed that would close on certain voltages, and those voltages would always be the same. So we can have a multifunctional relay here where we have different things happening for different applied voltages. I also think that's kind of cool. So with something like this, it's not just a straightforward relay where you apply a voltage, it's either on and off. Here we can apply a set voltage that we set down from a volt or two actually up to about 30 or 40 volts. So we can set the turn-off voltage. We can have it turn off, turn on immediately by just setting these two distances, and we can set, if we want to, a whole load of contact points so we get different actions for different voltages applied to that coil. I think that's kind of cool, actually. Anyway, I thought I would share it with you. It demonstrates a basic relay for sure, but it also could be expanded really easily to have a multifunctional relay doing lots and lots of different jobs. But I thought I would share it with you. I hope you enjoyed the video, and thank you very much for watching.